Hello and welcome. Today we'll be solving question number 2 from exercise 6.2. Let us move on and read the question first. Construct a tangent to a circle of radius 4 centimeter from a point on the concentric circle of radius 6 centimeter and measure its length. Also verify the measurement by actual calculation. Okay, the data out of the question is over here. The nature of the circles that we are supposed to draw are concurrent, and we are supposed to draw two circles, that is C1 equals to 4 centimeter and circle C2 equals to 6 centimeter. And we are also supposed to draw a tangent to circle C1 from a point of C2. Okay, let's get started and first draw a circle, and that circle is equals to 4 centimeter in radius. I'll take a center, I'll measure 4 centimeter in the compass, and now I draw a circle whose radius is equals to 4 centimeter. Since it is concurrent, considering the same center, I'll measure 6 centimeter in my compass. Once I measure 6 centimeter for compass, taking into consideration the same center, I draw a new circle. Okay, and now I'm supposed to draw on circle C1. Let's label them. This is equals to C1, and this circle, let's name it as C2. From a point on C2, any point for that consideration, you can take it any point, but conventionally it is better if you take a point along the radius of it. Okay, the blue dot that you see, that is the point that I have chosen. From that point of C2, I'm supposed to draw a tangent, in basically one tangent on circle C1. How do I draw a tangent? To do so, first I need a perpendicular bisector. So along that line, from either ends, I will have to first measure more than half. It can be more than half, it is all up to you. And draw two arcs. So I went short, hence I redid the things. And now I'll take a ruler, and with the help of a ruler, I will draw a line passing through the intersection of those arcs. And then from point, let me name it as P, and center as O, and the midpoint that we just got, I'll label it as M. And from point M, which is the center point, now I'll draw a circle. And this circle, let us label it. We'll label it as C3 for our reference. So the circle C3 bisects circle C1 at 2 points. Those are the 2 points, isn't it? So let us label it as Q and this point as R. What am I supposed to do now is draw the tangents from point P all the way up till Q. Similarly, Since only one tangent is drawn, all this is enough. Okay, if you don't understand whether I am supposed to draw one tangent or two tangents, in that cases, you can draw another tangent as well. But if you draw one tangent, that is all enough, because it has been asked for us to draw only one tangent. Singular is, the word tangent is singular in the question, hence one tangent is enough, that is PQ. Now construction is all over, isn't it? We got the tangent, that is what we are supposed to do, and we got it. Now for justification purpose, we need to draw a line joining OQ. For the purpose of justification, I am drawing a line from O to Q. I hope you all are aware that OQ is also equals to radius, isn't it? OQ is radius of circle C1. And you also know that QP or PQ, whatever, that is perpendicular to OQ. Two conditions. The first condition is OQ is radius of circle C1 and PQ is perpendicular to OQ. If these two conditions are satisfied, then you can claim PQ to be the tangent. That is what we'll be doing in justification part. I hope this is clear to all of you that PQ is the required tangent, isn't it? Now we'll move on for justification. Now we can claim that PQ and PR are the required tangents. In fact, one tangent is all enough. You can simply state that PQ is the required tangent. Now moving to justification. In triangle PQO, this triangle PQO, PQO, in this triangle, angle at Q is equals to 90 degree. You need to draw this 90 as well. And OQ is perpendicular to QP. OQ line is perpendicular to QP. But OQ is radius. This is radius. If these two conditions are satisfied, then we can claim that PQ is tangent to the circle. Now, justification of the second part, that is measurement. In triangle PQO, angle at Q is equals to 90 degree, isn't it? In PQO, angle at Q is equals to 90 degree. And from since it is right angle triangle, from Pythagoras theorem, hypotenuse square is equals to square of sum of square of other two sides, isn't it? Oh, I hope you all are aware of this. And PQ, I need PQ. I am supposed to find out the length of the tangent, that is PQ square. If you shift the things, this is what you get. Therefore, PQ square is equals to OP, this is the radius of circle C2 and that is equals to 6. And OQ is radius of C1, that is equals to 4 square. Actually, this root has to come to over here. So 6 is 36 minus 4 is 16. So you consider this root starting from 36, got it? And then PQ is root of 20. Square root of 36 minus 16 is 20. This is now how to find out the root of 20. This is how we find out. We write 20 over here, then we draw this line, then multiply it. The least number with which it can get multiplied is 4 4s are 16. I wrote 16 over here. And now subtraction. If I subtract over here, I am left out with 4. Isn't it? I have 20 over here. I will first multiply this with 4 4s are 16. If I subtract, I get 4, and this is very smaller number. To in order to make it much a bigger number, a divisible number, I need to put a dot, a decimal dot over here, and put two zeros over here. That is what I have done. And the same 4 I'll take over here. You all have gone through, you have been learning all these things since your 8th standard. And if I add this 4 and 4, what I have is 8. And what is the next step? I need to have some number and multiply that some number with the same number of here. In this case, I'm choosing 4. 84 equals to 4 is equals to 336. Fine. And what am I left out with is 64. And the answer that I have got is 4.4. Therefore, PQ is equals to 4.4. And with measuring with the help of a ruler, still we get 4.4. Hence, justified. Yeah, that's it. Thank you for watching.